So we're investigating sin x plus d, cos x plus d, so we're graphing y is equal to sin x first using the table, and then you have to complete the second table, which is sin x plus 1, okay? And then you're going to graph that, and we do them on the same axis. Okay, so this first graph that I'm drawing is sin x.
Oh, I already made 3.
Mistakes?
Yeah.
Wow, Grayson.
Oh, very good.
Doing it as neat as possible, please. Okay, make sure you're labeling your graphs as well. So that's our y equals sin x.
Yes, sir.
In order to get sin x plus 1, what are we having to do?
Something.
Yes, what is that?
Oh, sorry, can you repeat that?
So in order to get sin x plus 1, how do we work out these sets of
You just
values?
add 1 to each of them.
You add 1 to each of these values, okay. So this is going to be 1.5.
5.
1.5.
And then 90 is going to be 2.
90 is going to be, yep.
And then 120 is going to be 1.87.
1 plus, guys, what is 1 plus 1?
This is going to be 1.5.
Good job.
It is 11.
1. Now, listen, we need to be careful with these negative value ones, okay? We've got negative 0.5 plus 1, which is 0.5. You can always put it into a calculator to check. For the next one,
Maybe just say, can I have it?
negative 0.87.
Wow.
Adding on 1. Upright.
The table for y equals sin x 2. I mean, sin x plus 1. Not your table, I mean the
It's just good.
Yeah, it's supposed to be.
Yeah, would that be 0.1 or 0.13? Because I don't know how to plot that.
So it's
Yeah,
not
it would
supposed
be
to go under.
0.13,
I think it is.
okay?
I don't know how to plot that.
Okay, well, we'll do it in a second. This would be 0.5, and this one would be 1. Okay, so we've got all our values that we need, okay? Happy with that, Liza? Now, you can put the whole thing into the calculator. You can do sine of 30, and then add 1. Or you can just take these values, because this is what sine of x is, and just add 1 to them. Okay? So when you come to graph it, the first point is going to be right here. The next one is going to be at 1.5. Then 1.87. And 2. And then it's going to come back down again.
No, it goes on
Nice, stop. So 0.13, Eliza, is going to be, now what does each one of these little squares represent?
2.2.
0.2. Okay, so 0.1 is going to be halfway in between 0 and 0.2. So 0.13 roughly is going to be in there, okay? Okay, so what do we notice when we sketch sin x plus 1?
It's just one, everything's just one above
Yeah,
the
it's
middle
twice as
one.
big.
It's
It's
twice
like
as
a little
big?
cat.
That makes sense, so who
No,
thinks
and
that?
like the point like twice as big.
It's just, everything's one higher than the point below.
Right, okay, so the whole graph is
Yeah,
just,
yeah.
how can we say that it's, what's the word that I'm looking for, because it's done what?
Parallel.
It's unparalleled.
Parallel.
Parallelly.
Unparalleled.
It has shifted, okay, the whole thing has shifted
Boom.
up by 1 unit,
Boom,
okay?
boom, boom. Yeah.
Wow. You're so good.
Have you finished enough?
Sin x plus 1 has shifted. Now, the posh name for this is translated.
Off.
Translated by, I should say up by, translated up vertically by 1. So what do you think we're going to get when we draw our next one? What's going to happen if it's sin x? Right, the whole thing is going to shift just down 1, okay? So in this, how does the shape of y equals sin x plus 1 compare to that of y equals sin x? What are we going to write here?
It's the same shape, but it's
It
just
shifts
down
up, yeah.
on the
Same shape, but
Boom.
Oh, sorry,
sin x, what's the words I'm going to use?
Girl.
Guys, that's what I said. Just wrong.
translated down.
Translates,
Go down
and this one is up
What's
by
that? No, that means.
1 unit.
Yes.
This is sin x plus 1. What is the amplitude of, what is the amplitude of sin x plus 1?
Ooh. 2.
It's
No.
not 2,
It's
Oh,
one.
it's 1. Why is it 1, Ian?
Opposite, yeah. What else?
Or Liam, why is sin x, why is the
Because-
amplitude 1?
The from the highest point to the lowest point is 2.
Right,
And
okay.
then
Oh,
from 2
The highest point,
divided by 1 is like
the highest point down to the lowest point, that is 2 units. So the amplitude is still 1. Okay, what about the period? What is the period of sin x plus 1? 360 degrees, okay? The period is 360 because it starts repeating after 360 degrees. I fill in each of these.
Fair enough.
Sin x, take away 30.
It's not really.
Green.
I'm starting for confidence. For Somerset Eagles.
Somerset equals? The Somerset equals? That's the word name.
Alright, so there's my values for sin x minus 1. Okay, and when I come to plot them, okay, we're starting down at -1. We should be aware that the whole graph is just being shifted down. Okay, so those are my 3 graphs. That is what we are looking for. What do do we notice about the amplitude for each of them? Yes, it is. They are all 1. The amplitude is 1. The amplitude is not changing. What do we notice about the period for each of them? They're all what, John? 360 degrees. Okay, the period is not changing. Okay, the only thing that is changing is the graph is being translated. Okay, so it's being translated or shifted up or down depending on the value of b. We can say sin x minus 1 is the same shape as sin x. Set has been shifted, or the proper word that we should use is translated down by 1 whole unit. Okay, the important thing to remember is the amplitude stays the same and the period stays the same. When you get on to Desmos, which you should all be looking at.
Oh my gosh. No. How measures a tan x plus 1?
No. Nice.
Look, how did you get like the same yellow lines? What? Like you know you have
What's
this
your honey
the
now?
other
Mhm.
end back to this.
Afterwards, can you go back to this?
Yeah, we'll do
How
it.
do you do that? How do you like save them?
Okay, just quickly, I want to have a look. Just look at the graph. So this is when d is equal to 0. We have shown that when d is equal to 1, the whole thing, the actual shape of the graph, does it change? Does the shape of the graph change?
No.
No. Just its position, okay? So it moves up if d is positive. It moves down when d is negative, okay? It just translates up or down depending on the value of d. Does the amplitude change at any time? Does the period change at any time?
Just the trans.
Right.
Same, just maybe.
Okay. Translates. When you come on the other side to have to draw y equals sin x, it shouldn't be the case where you're having to put in every single point, okay? We know it starts at 0, okay? We know that it is going to go as high as 1 whenever it gets to how many degrees? 90. We know then it's going to come back down to
0.
yes, how many degrees?
180.
Okay, so I'm happy for you just to put in those points, okay? But for the purposes of doing the next part of the question, you need to fill out the table, okay? It's still going to look exactly the same type of shape. It's going to go as low as -1 at how many degrees?
240.
270, and then back to
36.
360, okay? So again, that is my y equals sin x. The second part of the sheet is going to help you draw y equals negative sin x, okay? And in order to do that, you have to add another row onto this table. start you off. And the next row is going to be negative sine x. Okay? Now if sine x is 0, what is negative sine x going to be?
Zero.
It's a 0. What about for the next value?
Negative 0.5.
Right, negative 0.5. And the next value?
Negative 0.87.
Right, what about when we get over here, Sana?
1.
It's going to be
All
1.
positive.
Positive 1, yeah, these ones are going to be positive because it's
Oh.
negative, negative.
Yeah.
Right, okay, and that is, we're then going to graph x with negative sine x, okay? Let's see the difference, okay? We can see what it looks like.
Wait a minute. What? Well, this is dumb review.
No.
Because why is it 0.1?
What's wrong, Grayson?
You may have already answered this, but why is it not negative 0.13 in like the third one?
For this one? Because we're doing negative sine of x. So sine x is 0.87.
Oh, so you just put negative numbers?
Negative sine x is just going to be negative with the negative of it. Okay? And I'm like, okay, these are my values for negative sine x, okay? Most of us have these down. And when I come to plot them, okay, what do you notice about them compared to sine x?
It reflects it.
Well, what do we notice about them in the table? I can't see any reflection in the table, but what do we notice?
You just do the opposite of one before. Each number's opposite.
What do you mean the opposite?
Like just with a negative.
Okay,
And then
if
the
one
ones
is,
that-
if these
and
are
then
all
the-
positive,
The
then
ones
these
that are
values
negative
are
are
all negative.
positive.
And the ones that are all negative all become positive.
I was gonna say, you can see a
what?
reflection.
Sue me. Go ahead.
You can see an opposite reflection in the chart.
Boo!
Chris?
What are you doing?
So when I come to graph this, I'll do it in a different color. It still starts at 0, but this time the values are going to be negative. And they go down to negative 1 again, 90. And then it comes back up. 1 second.
I'm just trying to.
This is our graph of y equals negative sine x. What do we notice about the amplitude of negative sine x? Its amplitude is 1. What do we notice about the period of it?
It's 360.
Okay, it is also equal to 360.
Wait,
We will
No.
finish talking about
it's 180.
it's
It's not,
360 because it
not.
starts to repeat
Never
at,
mind.
after 360 degrees.